Hello students and good morning. So now I'm doing class for class 12. The topic is the same topic that we were doing in the last online class, that is integration by the method of substitution. Same exercise 6a, page number 351, 5 mark section from the book Higher Mathematics for class 12 by Sailendra. So this is question number 18. So you have to integrate integral sine dx divided by 3 sin x minus 4 cos x. So how can you evaluate this integral? So we were doing this type of integration in the last online class also, and I told you the method how to integrate this integrals. Okay, so let us do this integration. So let us write first I is equal to integration of dx divided by, this is 3 sin x minus 4 cos x. Okay, now what is the method here? Now you have to check the coefficient of sin x and cos x. What is the coefficient of sin x here? The coefficient of sin x is 3. And what is the coefficient of cos x? Coefficient of cos x is 4. Coefficient of cos x is 4. Okay. So don't consider the sign out here. Okay, don't consider the sign out here. Let us write only 4. So this is 3 and that is 4. So now you should divide this 3 by what? Which number? You should divide this 3 by which number? Root over coefficient of sin x, that is 3 whole square, plus coefficient of cos x, that is only 4 whole square. Okay. Here also these 4 should be divided by root over coefficient of sin x whole square, that is 3 square, plus coefficient of cos x whole square, that is 4 whole square. Okay, and that means which is equal to 3 by, this will be 5, isn't it? Root over 9 plus 16. 9 plus 16 is 25. So square root of 25 is 5. So it is also 4 by 5. That means you have to multiply and divide the denominator by 5. You have to multiply and divide the denominator by 5. Is that clear? So now, therefore, I is equal to integral sine, this is dx divided by, so it is 5 within bracket, it is 3 by 5 sin x minus, it is 4 by 5 cos x. So I think you have understood it. Okay, so here 1 by 5 is constant, that is taken outside. 1 by 5 integral sine dx divided by 3 by 5 sin x minus 4 by 5 cos x. Is that clear? And now you can convert this expression into compound angle form, that is, always write it in the form of sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B. So here you can write, let cos theta is equal to 3 by 5 and sin theta is equal to 4 by 5. You can write it because the value for cos theta and sin theta both are less than 1. Values of both cos theta and sin theta are less than 1, that is correct. And here we can prove that cos square theta plus sin square theta is equal to 1. That is 3 by 5 whole square plus 4 by 5 whole square is always 1. That is, it will be 9 by 25 plus 16 by 25, which is equal to 25 by 25, which is equal to 1. That is correct. So we can take cos theta is equal to 3 by 5 and sin theta is equal to 4 by 5. So let us divide it. If we divide it, what do we get? Let us get the value for theta. Theta is unknown here. Sin theta by cos theta is equal to, what is sin theta in this case? It is 4 by 5. And what's about cos theta? It is 3 by 5, right? So here 5 gets cancels. So it is tan theta is equal to 4 by 3. Therefore, what is the value for theta? It is tan inverse 4 upon 3. Is that understood now? So let us put these values in I. So let us put these values in I now. Therefore, I is equal to 1 by 5 and integration of dx divided by what is 3 by 5? It is cos theta sin x minus what is 4 by 5? Sin theta cos x. It is sin theta cos x. Okay. So now what is the formula in the denominator that you can use here? It is sin a cos b minus cos a sin b. That is the formula, sin of a minus b. Or it is I is equal to 1 by 5 integration of dx divided by sin of what is a minus b? It is x minus theta. So what is this? 1 by sin of x minus theta, that is cosec x minus theta. Or I is equal to, this is 1 by 5 integration of what is 1 by sin? It is cosec x minus theta bracket closed dx. So we can take x minus theta as x. Here theta is constant, so we can take x minus theta as x to integrate it. So what is integration of cosec x dx? You know this, isn't it? Integration of cosec x dx is equal to log within mod tan x by 2 plus c. So or I is equal to, this is 1 by 5 log within mod tan, what is x by 2 here? X minus theta by 2, mod sign closed. Again you have to differentiate this function which is assumed as x. That is x minus theta is differentiated with respect to x. If you differentiate it with respect to x, you will get 1 minus 0. So it should be divided by 1. Since it is 1, you don't have to write it. So you have to write plus c. Now let us put the value for theta. Or I is equal to 1 upon 5 log within mod tan of within bracket, let us separate the term. This is x by 2 minus this is half. What is the value for theta? It is tan inverse 4 upon 3. You can write here, this is tan inverse 4 upon 3. Mod sign closed. Then what do we write? Plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 19. It is similar to question number 18. Let's do this question out here. So here you have to evaluate the integral, that is integral of dx divided by cos 2x plus root over 3 sin 2x. Okay, so now let us write first I is equal to integral sin dx divided by cos 2x plus root over 3 sin 2x. Okay, so now you have to simplify it first. You have to write down this denominator in compound angle form. But before that, what is the coefficient of cos 2x? It is 1. What is the coefficient of sin 2x? It is root 3. That means by which number will you multiply and divide the denominator? So by which number will you divide? By which number will you multiply and divide the denominator? What is the coefficient of cos 2x? Coefficient of cos 2x is 1. Coefficient of, what is the coefficient of sin 2x? It is root 3. That means you have to divide it by 1 upon root over coefficient of cos 2x whole square. 1 whole square plus coefficient of sin 2x whole square. That is root 3 whole square. Similarly, this root 3 should be divided by root over. So here also coefficient of cos 2x whole square. That is 1 whole square plus coefficient of sin 2x whole square, that is root 3 whole square. So which is equal to 1 by how much is it? Root over 1 plus 3, 4, that is 2. This is root 3 divided by 2. Is that clear? So you should divide you should multiply and divide the denominator by root over coefficient of cos 2x whole square, that is 1 whole square, plus coefficient of sin 2x whole square, that is root over 3 whole square, which is equal to root over 1 plus 3 root over, this is 4, so which is equal to 2. That means you have to multiply and divide the denominator by 2. Is that clear? So let us write here now. So I is equal to integration of dx divided by, let us write here 2 within bracket, half cos 2x plus, this is root 3 by 2 sin 2x. So I think I've understood it now. So half cos 2x plus root 3 by 2 sin 2x can be converted into compound angle form. So compound angle form means sin of a plus b form, that is sin a cos b plus cos a sin b. Always convert the expression into sin a cos b plus cos a sin b, so that we can use the formula of sin of a plus b. Or, so here I is equal to, this is half is constant taken outside, integration of dx divided by, since there is cos 2x here, write half in terms of sine. So sine of which angle is half? 30 degrees, isn't it? So sine of 30 degree in terms of radian is pi by 6 cos 2x plus, since there is sine 2x, you have to write root 3 by 2 in terms of cos. Cos of which angle is root 3 by 2? Cos 30 degree, that is pi by 6. So it is sine 2x. Okay. So or I is equal to, this is your half integration of dx divided by, what is the formula in this case? This is sin a cos b plus cos a sin b. What is the formula? Sin of a plus b, that is, let us write 2x first, then write down pi by 6. So it is 1 by sine. What is 1 by sine theta? Cosec theta. So or I is equal to, this is your half integration of, this is cosec within bracket 2x plus pi by 6 bracket close dx. So we have got the value for I. Is that clear to all of you? So now let us integrate it. So this is the form integration of cosec x, right? So you know that integration of cosec x dx is log tan x by 2, isn't it? So integration of cosec x dx is equal to, what is the formula? It is log within mod tan x by 2 plus c. Okay, so that is the formula you have to use here. So here what is x? It is 2x plus pi by 6. This 2x plus pi by 6 is taken as x. Okay, so this is cosec x. Therefore I is equal to half log within mod tan, what is x by 2 in this case? Here x is 2x plus pi by 6. X is 2x plus pi by 6, x by 2. Mod sign close. Now this whole divided by what? Whole divided by, now you have to differentiate the function which is assumed as x. So here 2x plus pi by 6 is assumed as x and it is integrated. So what is the differentiation of 2x plus pi by 6? It is 2x, for 2x it is 2, plus pi by 6, that is constant, it is 0, so it is only 2. So in case of integration you have to divide it by 2. You have to divide it by what? 2. Is that clear? In case of differentiation you have to multiply by the differentiation of 2x plus pi by 6, but since this is the case of integration you have to divide it by the differentiation of 2x plus pi by 6, so it is 2. Then what do we write here? Plus c. So or I is equal to, this is 1/4 log within mod tan of within bracket, let us separate the term. 2x by 2 is x plus pi by 6 2s are 12, mod sign close. This 6 and 2 will be multiplied and you will get 12, then plus c. So this is the final answer. So I think I have understood it. So this question is very, very important, so you can mark it. Okay, so now let's do the next question now. So now we'll do the next question, that is question number 20. So you have to evaluate this integration, that is integral of dx divided by root over 1 plus sine x. So first of all, you have to simplify the expression within square root, or you have to remove square root from the denominator. So you know the formula from submultiple angle, but there is no direct formula for 1 plus sine x. This sine x can be written as 2 sine x by 2 cos x by 2. And instead of 1, you have to write sine square x by 2 plus cos square x by 2. You know that, isn't it? From submultiple angle. So let us write here first, I is equal to integration of dx divided by within square root. For 1, you can write sine square x by 2 plus cos square x by 2 plus, what is the formula for sine x? It is 2 sine x by 2 cos x by 2. Is that clear? Or I is equal to integration of dx divided by within square root. So what is the formula that you can use here? A square plus b square plus twice ab. That is your a plus b whole square, right? So it is sine x by 2 plus cos x by 2 whole square. So that is your a square plus b square plus twice ab, which is equal to a plus b whole square. So now you can easily find out its square root, or I is equal to integration of dx divided by, this is your, what is square root? Sine x by 2 plus cos x by 2. So I think you have understood it now. So now here you can use the same method as we have done in the previous one. So what is the coefficient of sine x by 2 here? It is 1. What is the coefficient of cos x by 2 here? It is 1. Here a is equal to 1 and b is also 1. So by which number will you multiply and divide the denominator? That is, you have to multiply both the numerator and the denominator by root over coefficient of sine x by 2 whole square. What is the coefficient of sine x by 2? It is 1. That is your 1 whole square. Plus, what is the coefficient of cos x by 2? It is 1. So it is 1 whole square. So which is equal to, this is your root 2. That means you have to multiply and divide the denominator by root over 2. So let us write here, I is equal to integration of dx divided by, it is root 2 within bracket 1 by root 2 sine x by 2 plus 1 by root 2, this is cos x by 2. Is that understood now? So now next, in the next step, we can write here this in terms of compound angle form, sine a cos b plus cos a sine b. Okay, so or I is equal to, here 1 by root 2 is constant. 1 by root 2 is constant taken outside. Integration of dx divided by, now here let us convert into the form of compound angle, that is sine a cos b plus cos a sine b. Now since there is sine here, let us write 1 by root 2 in terms of cos. So cos of which angle is 1 by root 2? That is cos pi by 4, right? Next sine x by 2. Next sine x by 2 plus, again there is cos x by 2. You have to write 1 by root 2 in terms of sine. Sine of which angle is 1 by root 2? That is sine pi by 4. That is sine pi by 4 is 1 by root 2. Then you have to write cos x by 2. Then you have to write cos x by 2. So I think you have understood it. So this is the same method as we have done in the previous one, right? So or this is I is equal to 1 by root 2 integration of dx divided by. So what is the formula that you can use in the denominator? This is sine a cos b plus cos a sine b. That is your sine of a plus b. So here it is sine of, what is a plus b? X by 2 plus pi by 4. That is your sine of a plus b. Now what is 1 by sine? It is cosec, or I is equal to 1 by root 2 integration of, now this is your cosec x by 2 plus pi by 4. Then what do we write? We write dx. Is that understood now? So now this is in the form cosec x by 2 plus pi by 4 can be taken as x. This x by 2 plus pi by 4 can be taken as x. So it is cosec x dx. We can use this formula here again. Okay. Or I is equal to 1 by root 2. What is the formula? Log within mod tan of within bracket x by 2. What is x by 2? X by 2 plus pi by 4 is x divided by 2 mod sign closed. Now this is the case of integration. Again you have to differentiate the term which is assumed as x. That is x by 2 plus pi by 4 was assumed as x. So what is this differentiation? For x by 2 is differentiation with respect to x is half plus pi by 4 it is 0. So this is the case of integration. So you have to divide it by differentiation of x by 2 plus pi by 4. That is, it is half. Is that understood? Then we have to write here plus c. So if the integration is done, then you have to write down constant in the last step, or in the answer you have to write down the constant of integration which is c. Okay. So now in this case, this half, when it goes up in the numerator it becomes 2. So or this is I is equal to 2 by root 2 log within mod tan of within bracket. Let us separate the term. X by 2 2s are 4. This 2 and 2 will be multiplied plus pi by this 4 and 2 will be multiplied 8 mod sign closed plus c. So here you can cancel. Root 2 1s are root 2. Root 2 2 like times? Root 2 times. So or I is equal to, this is your root 2 log within mod. This is tan of x plus pi by 4. X by 4, that is tan of tan of within bracket x by 4 plus pi by 8. First bracket closed, mod sign closed, then plus c. So this is the final answer. So this question is also very, very important. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 23. So these two are your homework. I'll give you the hint only, okay? So question number 21 is integral sine dx divided by x log x within third bracket log of log x. So this is the method of substitution. You can directly do it. If you differentiate log of log x, what is the differentiation of log x? 1 log x form 1 upon log x. Again differentiate log x with respect to x, 1 upon x. That is, we're getting 1 upon x log x. So we can assume here, let z is equal to this expression within third bracket, that is log of log x. Is that clear? So if you differentiate it, you will get 1 upon x log x. Okay. So here also you can do it. Number 22 is also your homework. I'll give the hint. Integral sine x plus x cos x dx divided by x sin x. So differentiate x sin x. Are you getting the numerator? X sin x, you can use UV rule. For x it is 1 and sin x is kept as it is, plus again x is kept as it is. What is the differentiation of sin x? That is cos x. So if you differentiate the denominator, we are getting the numerator. So here also we can assume let z is equal to x sin x. So this is also your homework. So now let's do this question number 23. So now we have to evaluate integral of, this is tan square x dx divided by sec x minus 1. So let us assume I is equal to integration of tan square x dx divided by sec x minus 1. Okay. Can you do the method of substitution directly here? What is the differentiation of sec x? It is sec x tan x, but it's not tan square x. But here you cannot use the method of substitution directly out here. Okay. But you can express tan square x in terms of sec square x, isn't it? So you know this formula, that is sec square x is equal to 1 plus tan square x. You know this formula, right? So what is the formula for tan square x? It is sec square x plus 1 is taken to the left hand side, so it is minus 1, which is equal to, this is your tan square x. So what is the formula for tan square x? It is sec square x minus 1. Let us put it out here. Or I is equal to integration of, what is tan square x? Here you can write sec square x minus 1. Let us put it in bracket. Dx divided by, this is your sec x minus 1. Is that clear? So now in the numerator, again you can use the formula, but that formula is from algebra. That is your a whole square minus b whole square. So what is a square minus b square? It is a plus b into a minus b. Or I is equal to integration of, this is sec x plus 1 into sec x minus 1. You know this formula, isn't it? That is sec square x minus 1 will be a square minus b square, which is equal to a plus b into a minus b. So this whole divided by, this is your sec x minus 1. Then what do we write? Dx. Is that clear? So now we can cancel here. This sec x minus 1 will be cancelled. So write down the remaining terms. I is equal to integration of, this is sec x plus 1 dx. Is that understood? So now let us separate the term and then you can easily integrate them. Or I is equal to integration of sec x dx plus integration of dx. Okay. So both are formula out here. So what is the integration of sec x? You know that in method of substitution you did integration of sec x. What is integration of sec x with respect to x? I is equal to log, within mod it is sec x plus tan x, mod sign closed. Okay, then plus, what is the integral sign dx? That is your x plus c. So this is the final answer. So I think you have understood it. So these two are a homework. These two, that is 21 and 22, will be a homework. So you can revise this number 23. Okay, so I hope you have understood it. So this much is for today. So in the next online class, we will do more problems on this integration by the method of substitution. Okay, so this much is for today.